Hi students, this is Alex here. In this video, we are going to do the Taylor series expansion for the given function which is e power x into log 1 plus y. So let's take this as f of x comma y, that is e power x into log of 1 plus y. And here the value of a and b are 0 because this is only x. Usually it is x minus a. So a is 0 and y minus b. So b is 0. Now let's find f of 0 comma 0. When I put 0 for e power, it will become 1, and when I put y as 0, I'll get log 1. Log 1 is 0. And e power 0 into log 1. Anyway, log 1 is 0, so total term is 0. Now let's find the derivative fx, partial differentiation with respect to x. So e power x will be e power x only, and log 1 plus y is constant, so we will write it as it is. Now for fx, we have to put 0 comma 0 for x and y. So once again it is same term, so it will be 0. Now let's find fxx. This is e power x. Again log 1 plus y is constant, so fxx of 0 comma 0 will be 0. Then third derivative with respect to x. Once again e power x is e power x, and log of 1 plus y is constant, so fxx x 0 comma 0 will be 0. Now let's find fy. So here e power x is constant, and the differentiation of log 1 plus y is 1 by 1 plus y. Now fy of 0 comma 0 will be e power 0 into 1 by 1 plus 0. Anyway, e power 0 is 1 and 1 by 1 is 1. So totally this is 1. Then let's find fyy. So here we have to write the constant e power x as it is. Then this is of the form 1 by x. So minus 1 by x square. So minus 1 by 1 plus x whole square. Now fyy of 0 comma 0. Anyway, this is 1. And when I put 0 here, denominator is also 1. And totally there is a minus sign, so minus 1. In the same way, we have to find fyy, which is again e power x is constant, and minus 1 by x square differentiation is 2 by x cube. So 2 by 1 plus y whole cube, and when we take the values for x and y as 0 and 0, we left with only 2. We also need fxy, and fxy is nothing but this fy we have to differentiate with respect to x. So 1 by y is 1 by 1 plus y is constant. So e power x is e power x, and this constant will be as it is. Then coming to the value fxy of 0 comma 0, this will be 1. Then we also need fxxy. It means differentiation of this previous term with respect to x. Again e power x is e power x, and 1 by 1 plus y is constant as it is. So fxxy will be finally 1. And we also need fxyy. So fyy we have to differentiate with respect to x. So e power x is e power x, and the remaining things are constant. So we will write e power x into minus 1 by 1 plus y whole square, because the entire y is constant, so we write as it is. And again f of xyy of 0 comma 0, everything is 0 comma 0. So this will give us totally minus 1. Now we are going to write the Taylor series expansion formula f of x comma y equal to f of a comma b plus 1 by 1 factorial into x minus a fx of a comma b plus y minus b fy of a comma b plus 1 by 2 factorial. After writing this term, using this we can write the other terms. This is of the form a plus b. So now we have to write a plus b whole square. So a square f xx of a comma b plus 2ab. So 2 into x minus a y minus b, then f xy of a comma b, then b square term y minus b whole square into f yy of a comma b. In the same way, we can write a plus b whole cube form for the next term, that is 1 by 3 factorial a cube. So x minus a whole cube into f xx of a comma b plus 3a square b. So a square b, and this will have f xxy of a comma b, then plus 3a b square, and this will have f xyy of a comma b, then plus last term is b cube term. So y minus b whole cube, y minus b whole cube, f yy of a comma b. Now we have to substitute all the values. So in the question it is given e power x into log 1 plus y as f of x comma y. So on the left hand side, for f of x comma y we have to substitute the function e power x into log 1 plus y. Then the first term f of a comma b, which is here 0. So first term is 0. Then plus 1 by 1 factorial, x minus a is x, and fx value here 0, and fy is 1. So this is 0, then plus y into 1. In the same way, 1 by 2 factorial x square into fxx. fxx is also 0, so this will be 0 here. Then plus 2ab term, so 2xy fxy, which is 1. Then into 1. Then finally y square into fyy. fyy is minus 1. So this is minus 1. Bracket close, plus 1 by 3 factorial x cube into fxxx is 0 plus 3x square y into fxxy. fxxy is 1. So it is 1. Then plus 3ab square into fxyy. fxyy is minus 1. So we put minus 1 here, and the last term is y cube into fyy. So fyy is 2. So last term is y square into 2. Now let's rearrange the term. So e power x into log of 1 plus y gives, first term is only y. Then second term, if I multiply this 2 here, I will get only xy. In third term, minus y square by 2. Here this is 0, and this will be, after cancelling 3 factor is 6. After dividing, this will become x square y by 2. Then minus x y square by 2, and the last term is plus y cube by 3, because this is 6. When I multiply, after cancelling, we are writing the remaining number. So we completed the Taylor series expansion up to third degree.